Yeah, so my name is Paul Lammertsma. I work in the Netherlands in a company called Pix+D. We're based in Utrecht. We're an app agency. We develop apps for larger companies and also embedded systems and custom firmware. Yeah, and I'm the CTO of this company. This particular talk is about Chromecast, or Google Cast. What is Google Cast? Well, when this talk was originally made in 2 years ago, the only Google Cast compliant device was Chromecast. Who here knows another Google Cast device? Yes, you over there. An Android TV device, yes. Indeed. So such as the Nexus player is also Google Cast compliant. And embedded TV system that can run Android TV, exactly. So when this talk was originally made, it was talking about the technology in itself, and that has now become relevant. So that's fun to see. So what is Google Cast? It is basically, if we're talking about Chromecast, a way to get, if you plug in your Chromecast to your TV, a method to basically, if you look at the device here in the corner, you see that there's a Chromecast button, and you can basically control media on the big screen through a handheld device or from your laptop or tablet. So you can, for instance, control Netflix or YouTube or any device or any application that has Chromecast SDK embedded in it. So Google Cast actually originally was launched with a couple of pretty cool apps: Netflix, YouTube, like I mentioned before, Google Play Movies, of course, and the other Google Play series of music and TV. And what it allows you to do is it allows you to stream this content on your TV. So what is actually happening, the Chromecast is streaming the content through HDMI onto your dumb TV. Let's say we don't have a smart TV, so you have a dumb TV. And the way that you control the content is actually through your mobile device. So you would have, for instance, the YouTube application, and instead of watching the video on your device, on your handheld, you would just see a thumbnail of the video that you're watching, and it would be overlaid with a play and next video or a pause button or something like that to control how the playback occurs onto the TV. Well, what we really came here for, what you guys are here for, is not about what Chromecast is, because you can buy one in the store and you can figure it out yourself. But of course you want to figure out how to make your own apps for Chromecast. So what do you need? Of course you need a device. You need a Chromecast device, for instance, or a Nexus player. You of course need a TV that supports HDMI connection. And the Chromecast will then connect through Wi-Fi, and that Wi-Fi needs an internet connection. So sometimes when I give this talk at a conference where there's a bit of a spotty internet connection, that's going to be a real problem because it actually has to be able to communicate over the internet. And I'll explain why that is a little bit later. And in order to power this Google Cast device, you also need some sort of power. Either you can plug it straight into a wall socket USB adapter, or you can plug it in if your TV so supports using this USB connector or your TV if it supports power. And of course, a sender device. What is a sender device? That is basically a handheld device, like your cell phone or something like that. Okay, cool. So if we're talking about Google Cast, we're talking about two distinct things. First of all, you have a sender application, and you also have a receiver application. In this particular talk, I'll be talking mostly about the sender application because this is Droidcon after all. We're mostly interested in Android. And we want to see how the Android sender application actually works. So the Android app then uses the Chromecast SDK, and you can also actually control it via your laptop if you install inside Chrome the Chromecast extension. Then you can also use it through your laptop. And the receiver app is actually just a really simple single-page HTML application, and it uses, of course, a lot of JavaScript to enrich that application. How does the sending and receiving actually occur? Well, everything occurs through communication channels. This is, of course, sending and receiving data. And the nice thing about it is that you can actually have multiple sessions. You can have multiple channels. That allows you, for instance, the possibility, if, for instance, I am watching something on YouTube on the TV in the living room, if my girlfriend wants to join, for instance, she can just open up her phone and join in on my existing YouTube session. And she can add videos to the TV queue. So you have multiple sections. You have multiple communication channels. You have one receiver app, and you have multiple sender apps. This looks complicated. It's really not. We'll break it down a little later on. But this is a general impression of the flow of communication that you'll be dealing with when you're dealing with the Google Cast SDK. You launch your sender application. You discover any cast compliant devices on the network. You connect to that device, you then launch or join an existing receiver app, you send and receive messages, and finally, of course, and that is, of course, a loop, basically. As long as the receiver application is running, you continue to send and receive messages, and then finally, you disconnect. And from that point on, of course, you can launch a different application. We'll go into a little bit more detail a little later on. So, about the senders then. And by senders, remember we're talking about handheld devices, tablets, and laptops. So these can be Android, iOS, or Chrome. What the sender is responsible for doing is discovering cast devices on the network. If it finds a device on the network, then and only then should it actually provide the cast button in the UI. Why is this important? Well, because if you show a cast button in your UI, for instance, if you do so in the YouTube application, and you don't have a cast compliant device on your network, a lot of users are going to have a really weird experience. The button doesn't do anything. So just don't show it if there aren't any devices on the network. We'll get into a little bit more detail how and why that is. So you can start or join a session with any cast device. So this is the 3 responsibilities that a sender application really has. The receivers are really this single page HTML applications that I was talking about before. Their content is actually online. They're loaded from the network somewhere. That's not entirely true. If you want to have a really nice, custom-built receiver application, in that case, it is loaded from the internet. And for this, you'll need a internet. You'll need a Wi-Fi connection with internet. And finally, this receiver application is identified uniquely by an ID. I'll show you exactly how that works a little later. And for this reason, because it is identified by an ID, that is the reason why your Wi-Fi needs internet. Because what is happening under the hood is that ID is being looked up from the Google's HTTPS servers to figure out where that content is actually being posted. And finally, of course, this communication then occurs over a message bus to your handheld device. Right, so this is why it needs unobstructed access to the internet. Okay, so there are 3 distinct types of receiver applications. You have default media receivers. These are really just for media playback. You'll see this sometimes when you just want to play a video. If you're familiar with Chromecast and you play with it, running applications, you might be familiar with Localcast or Allcast. These are applications that allow you to, for instance, play a video that you shot on your handheld device immediately onto your TV. There's no interface on the TV whatsoever. It just plays the video, and you can start, you can pause and resume it from your device. The style of media receiver is a little bit different. You can provide CSS, and you can, in that way, give it a little bit of custom look. And finally, of course, the most interesting thing, at least I think so, is a custom receiver, and you can make it whatever you like. Any HTML page that will run in Chrome, any single HTML page that runs in Chrome, of course with the JavaScript and CSS, whatever you like, you can make that. And this does require a special library from the media player, but it really provides you a very broad possibility to build what you want to build. And these last 2 options, at least in the Netherlands, they cost a whopping 5 years registration fee, so it's really an investment in your development. I think it's worth it. There's some documentation. You can look this up. The slides will be available later. I do want to point out, though, that the design checklist is really a fantastic tool to be able to understand the basic flow and to have the forethought and the foresight to be able to see what some common pitfalls are before you run into them. So, I would definitely at least recommend looking at this checklist, and of course, developer guides and the API reference if you're going to do a proper read the fucking manual. There are samples on GitHub by Google's Cast team, and these are samples for all platforms, so not just Android, not just iOS, but also samples for using it in Chrome through the Chrome extension. There's also a community. That's a huge URL that doesn't fit. Shorten it a little bit. The Cast community. When I was writing this 2 years ago, the community was extremely active, and Google's engineers were literally at the ready to answer your question. I'm not sure if that's still the case, but in any case, there is an active community for this. Okay, great. Now let's drill down into the details of this Android Center. This is what we came here for. No more bullshit. Does mean we need a little bit of preparation. If you go to the Google Cast SDK Developer Console and you register your Cast device, there are a couple of things that you need to make sure that you do. You have to add a new application here. Here's my Cast demo that I use for this particular one. Note that here I haven't published it. You don't have to if you want to do some testing. But if you don't publish it, you have to make absolutely sure that your devices that you've added through the serial number are in the status ready for testing. If you don't do that, you'll be trying to launch your application onto Cast, and nothing will happen, and you'll have no idea why. There's nothing worse in debugging than trying to figure out why something doesn't happen. So a little bit of preparation, a little bit more preparation. Register your device through the Chromecast settings application by checking this really vaguely ambiguous checkbox that says send the Chromecast serial number when checking for updates. What that actually does is it correlates this particular device, if I go back a slide, with the device you had registered here as a serial number that's ready for testing. So it allows you to be able to test your application before it goes live. Okay, a little bit more preparation. This takes a bit. The Android support v4 media router is required, which also requires the app compat, so there's a little bit of Gradle dependencies you have to throw in there. Google Play Services is required. And if you want to make things easy for yourself, I would recommend using the Cast Companion library. And I don't mean that sarcastically, because it kind of conceals the way that things really work. So if you don't use it, it might be good for your development as a developer. But it is a lot of code and it could be pretty intimidating to do. So for convenience, you may want to use it. All right, let's take another look at this complicated flow we were talking about earlier. Let's break that apart with an awesome animation. So launching the sender. How this actually happens. Okay, what you have to do in your sender application is you have to add a button for Cast. There are a couple of options you can choose from. There are two that are available by default through the Cast SDK. That's the Media Router Action Provider. That is, of course, an action bar button, which, like I said 2 years ago, this was up to date. I'm not sure if that is now called a toolbar provider or something like that. But in any case, that is the way it was called at the time. The Media Router button is a generic button that you can place somewhere in your layout that allows you to communicate with the Cast device, or you can write your own. In the demo that I use, it actually uses the action provider. And then only show this button, of course, like I mentioned before, if a Cast device is actually discovered on your network. What this looks like in YouTube is something like this. If you have ever done it before, you might have seen this icon, of course, the Chromecast icon. As soon as you tap on it, it will show you a list of devices. We'll see that on the next slide. Here's what it looks like if you're actually already in playback. Once again, the Cast action provider button showing up right there. Okay. Here's a sample implementation of this action provider. It's just our menu resource layout, resource XML. Inside this, we have an item that provides an action provider class. So I'm not going to go into a lot of detail. This looks maybe a little bit more complicated than it might seem if you're not familiar with using action providers. And then, you're still in the process of trying to launch the center application. So you then get an instance to the media router, and you create a media router root selector for the Cast applications. This is a specific type, so that you only select those media root selectors that are applicable for Cast. And then you create a media router.callback for any discovery events. And that's actually the point which you can see that there is a Cast device available on your network. If we take a look at this in code, nothing has changed here. I've just moved these notes into comments, and I've added the applicable code. Here we see the media router.get instance, just providing a context into that to obtain it. And we have a new media root selector.builder. And we're adding this control category that specifies I only want cast media controls, and I provide my cast application ID in that. So remember earlier I was talking about having a application ID. This is where you insert it. We'll see it in another place later on, but this is one of the places. Finally, of course, building that, we will obtain an instance of a media root selector. And then we can create a media root callback. This is well, obviously it's my media root callback, so what does this implementation look like? I guess that's in a different slide. Add media root callback in on resume and remove it in on pause. The reason for that is you want to be conservative with battery, and you only want to make sure that you are trying to discover cast devices on the network while the application is in the foreground. And that makes sense, of course, because if the cast button is how you connect to it, if the application is not in the foreground, the user cannot interact with it. Makes sense, doesn't it? So, when we're trying to discover our devices, this is still in step 2. Again, here, add the callback to starting the device discovery. This is in our on resume. We add the callback to the media root selector. We add the media root callback that we defined before. That was that my media router callback, if you recall. Providing this instance that we created of the media root selector for cast client devices. And we provide here a particular type of callback. It's a flag for the type of discovery we want to do. I believe I have a note about this. I do indeed. A callback flag for performing an active scan is an alternative. The benefit of doing this is it can be faster. What is actually happening under the hood, if you're a bit into networking, is what is actually occurring on the network is it's performing a broadcast to which all cast devices will immediately respond. And if you instead use this one, it just waits for the next broadcast to happen naturally. So using the flag request discovery can have a little bit of a delay, but it uses less power, and this one vice versa. And of course in the on pause, removing that callback. Great. So we have now discovered, or we may presume to have discovered, a cast device, and we want to connect to it. So when a root is actually selected, you obtain the cast device associated with that root, and then connect to it through using this this object called a Google API client. What does this look like if you think in terms of UI? Again, the example from YouTube. When you tap on the Chromecast button, it'll give you an option. It'll have now discovered Chromecast devices on your network, and it knows that there is at least one. So in this particular example, it says the Office Chromecast, and you can tap on that. Maybe not the best example, but if you, for instance, are at home and you have one in your living room, and one in your bedroom, and one in your guest room, then you may have multiple Chromecast devices, and you can select which device on that same Wi-Fi network you want to connect to. Okay, wall of code here. Let's see what's going on. So we want to obtain the cast device from the selected root. How do we do that? Well, the root in the callback that we obtain a root object, and we obtain a bundle. So this extra provides us with a bundle, and we can then obtain the associated cast device with that. And then using the cast options builder, we can then do another listener. So this is going to be quite a mess of callbacks. Sorry about that, Josh. I know you hate the callbacks. Yeah, so what we can do is here we can then provide into that builder, we can say, hey, we want to use the cast API, provide those options that we've defined here above as the cast options, add a connection callback, add a optional connection failed listener, go ahead and build that and immediately connect to it. So this is really where the magic happens. And what does our connection callback actually look like? We have two methods that we can override. We have the onConnected here, which then actually has some method that I've defined that actually performs the launching of the receiver app. And that'll, I'm going a bit too fast. Let me just point out here that if the connection is suspended, that can happen. You might want to wait for the next onConnected and then re-establish your message channel. I haven't done that. I don't believe I've actually done that in the sample either, if you look at the GitHub. But it would probably be good practice also to handle the disconnects better. So how does the launching of the receiver app actually occur? This is one of the last steps before we actually can start exchanging messages with our receiver application. So you can either, as I mentioned at the very beginning, if you recall, you can either create a new session or you can join an existing session. This is important to point out in just a moment. I want to take a quick little intermezzo here. This is, by the way, a great moment in your UI of your application to show something to the user that something is happening, that something has been successful. In the YouTube application, they overlay the video with a progress spinner showing connecting. You should definitely do that too, because it can actually take a while before the receiver application has actually loaded up on the Chromecast. So our method that we saw before, this launch app, what does this actually do? Well, we take the cast API and we execute on that a method called launch application. And here again we see this cast app ID. And we're using the Google API, we're using an instance of Google API client to communicate. We'll be using that later on to send and receive messages through that API client. And then once again, I hope this is the last callback, we set a result callback. Now, this is for launching a receiver app. What about joining an existing one? There's a different method called join application. And it's very much the same, but you provide here a session ID. And the session ID can be useful in the case that you are re-establishing a broken connection. So for instance, if you're playing something on YouTube, and perhaps your mobile phone runs out of battery, you plug it in, you boot it up again, you can reconnect to an existing session. So it's something you may consider saving, storing, keeping a persistent state or something like that. That part is actually really up to you. The result callback, so when you obtain the result from actually launching the receiver app, at this point we can assume that our receiver application is up on the Chromecast and that it's showing on our TV. And that's of course only if the status is actually successful. And then we can set up, oh no, there's one more callback, sorry about that. So we can define a new callback when we receive messages. And we'll do that here. So each time we obtain a message, we can then respond to that message or somehow handle that message inside the context of the sender application. This cast namespace, what is the cast namespace? That is a URI of a very interesting style. I'm not exactly sure where that comes from. All you need to really remember is the URN : xcast : and then your package name. But of course, this is all right. Take care for joining applications. So, what happens if you disconnect from a session? You have a YouTube session open. So again, this example of my girlfriend and I watching things on YouTube. Suppose I disconnect from YouTube. It would make sense that the YouTube receiver application stays open on Chromecast because it's only me that's left. Perhaps my girlfriend's still interested in still watching things on YouTube. So it would be sort of unfair to disconnect if I left. And the other thing is, of course, when you're trying to join an application, you don't know actually if there's anybody already running a session in YouTube on the TV. So what I've done here is I've actually taken I've created a field that's just a simple boolean saying, hey, try to launch it. If that doesn't work, so first try to join it. If that doesn't work, then try to launch the first session. Does that sort of make sense? I kind of get the feeling that was a little bit of a rambling. Does that make sense to everybody? Okay. Now, exchanging data over that message channel that was now set up. Sending and receiving messages. What happens, well, what is a typical use case of this? YouTube, again. If you press pause in the YouTube application on your phone, it of course should send some message to Chromecast that you want to pause the video. Or, for instance, adding videos. In turn, you also want to receive messages from the Chromecast device because you don't have a direct connection to other devices in the living room. So if you have multiple sessions, you want to, for instance, know in the TV queue that somebody else added something. And this is a fantastic mechanism that you have a centralized server that knows what all those videos are. Anybody guess what that server is? It's the Chromecast. Chromecast, of course, is keeping track through the single-page HTML which videos are in the TV queue. So if device A adds video to the TV queue, the Chromecast device, through the receiver application, can then send a message back to all of the other devices, for instance, device B and C, that device A has added this video. So it's a really easy way of having a message exchange between devices through one centralized place. Sending messages would work something like this. Again, the cast namespace is provided as a parameter here. This message is just a simple string. When I first looked at this, I was thinking to myself, a string, that's kind of a weird way. I don't want to just send a string. It would be some sort of, some kind of binary data or so. But this is actually really convenient because you can define your own data type. You can make something in JSON, for instance. And what I ultimately did is I actually used this particular demo that's available, and I'll share the link to GitHub. Is I defined my own JSON protocol, I guess you could call it. So when I actually send this message, I can also provide a result callback on that. Another callback. To know if that message was actually received or not. If you're this application that I wrote is actually a simple chat application. You can chat onto a big screen, and all the chat messages that you add as one user will show up on the other users' devices as well. So it shows a couple of different things. Well, what happens if I send a message and I get this result callback that wasn't successful? Well, maybe a good thing to do then is try to send a message again, right? So you can continue doing this each time, for instance, that you press send on the action button, maybe in your application, to actually send a chat message. You can then keep on doing this cycle of sending messages and receiving messages until at some point you decide that you want to disconnect. There's a slide here that I didn't quite count on. This is for receiving messages. It's very much similar. This is our message received callback that I defined several slides ago, but I never explained what it actually looks like. This is the on message received. Again, you see as a parameter there that the message is just a string. So, of course, you would have this exchange between messages. It's still in our same protocol that we can define ourselves. So, of course, handling disconnecting. What are some things that you need to do when you disconnect? You have to unselect your root. There are several different scenarios in which this can actually occur. Either your root becomes unselected. This can happen, for instance, if somebody else takes your session. If you launch a different application on a different device, your root can become unselected. That makes sense, for instance. I keep on going back to the example in the living room. I'm watching YouTube, well, my girlfriend decides she wants to watch Netflix. Well, Chromecast can really only show one thing at a time, can't it? So at that point, you get a callback in one application that the root will become unselected. Connection failures can of course occur. Wireless networks tend to be unreliable. And of course, when the receiver application is stopped manually. Perhaps you also want to do something when your sender application is physically, stopped. But that's optional. You can unselect the root manually by pressing the Chromecast button and actually disconnecting. Cool, so what does our disconnect logic actually look like? Here you see an example. So if we have an existing client, an API client, and it's connected, stop the application, remove the message received callbacks, and finally disconnect. And for the state of our application here, we also set this client, API client to null. Right, now that was writing a sender application, so we're halfway there. Yeah. We're not going to write a receiver application. It's not in the context of this talk. It's HTML, it's JavaScript, it's CSS, and those are three technologies I don't know much about. So I'm not going to try to write that, but I'll tell you one thing. If I can do it, so can you. I will talk a little bit about debugging in a couple of batches. If you are trying to figure out why your receiver application isn't working quite as you expected, there's a fantastic tool. You can simply type in your Chromecast's IP address into your browser, and if you provide this port number into it, you actually get your entire Chrome DOM inspector. And as you're completely used to it, if you're a web developer and you mouse over different DOM elements, they'll actually highlight on your Chromecast, and it's absolutely a beautiful tool for debugging why things aren't working. So that includes a console for JavaScript debugging and the whole shebang. And you can figure out what that IP address is. It shows it right here at the bottom from the Chromecast settings. Okay, like I said, there are a few gotchas. I noticed in several scenarios that I would be trying to test something on my Chromecast and it just wouldn't launch, and it's extremely infuriating. So again, I want to emphasize, ensure that your device is ready for testing. It's really important that you go through those steps that I mentioned at the very beginning. Make sure your device is ready for testing. Make sure that this checkbox is checked, and make sure that your application is registered. You're providing the correct application ID. It's also kind of counterintuitive to be able to, inside the context of your application, to have to deal with the life cycle of a different application running on a different device. So what do you do when your sender application stops unexpectedly? Do you break the, do you stop and disconnect the receiver application as well? It's something you want to consider. Handling unexpected disconnects. You'll see in the demo code that I have in GitHub, I do not do that. So maybe you can. Pull requests always welcome. And simply forgetting to start the media router scan. I put that out there because I totally did that, and just sitting there waiting, twiddling my thumbs. Why is that not showing up? Right, again, that useful stuff. Check out the documentation, the samples, the community. They all have fantastic resources for getting started, and it's a lot easier than you may think. One final remark about added value. In the case that 2 years ago, it was at least the case, and I still believe that it is there's a special area on Google Play where applications are showcased that have Google Cast support. And I'll just look to Damien really quick all the way in the back. Is that still the case?
I don't have the answer, but I believe there is still featuring for a Chromecast ready application.
Cool. Okay, so yeah, they still feature Chromecast ready applications. And they have this gorgeous badge that you can use on your website. So. Right, that wraps it up. So I hope you enjoy creating your own Chromecast application. I hope you enjoyed my session, and thank you so much. I'd love to take any questions. I have time. Do you have time for questions? Does anybody have any applications that they can think of that would be really cool? That's all right. That's all right.
Internet radio on your TV.
Internet radio on your TV. I like it. I like it. Good. It's interesting, actually. I'll say something about that. There is Google Cast is now also available for devices without a screen, so you can actually cast audio onto, for instance, I believe Pioneer has a Google Cast receiver, so you can actually play audio over that. Something that I notice frequently when I'm in my living room and I just want to use YouTube or something like that to play some music, is it kind of bothers me that my TV is on the whole time. Or when you're playing Google Play Music or something like that. But of course, when you switch off your TV, it switches off your Chromecast, and in turn, you don't have any audio either. So, yeah. It's a great idea. Make it happen. Go Frank. Do it. All right, cool. Thank you so much.